Welcome to The Explainer, where we break down big topics. Today, we're diving into a moment that felt like a real turning point in spaceflight history, Starship's 10th test flight. This was a mission that truly had the weight of an entire program on its shoulders. Okay, let's just get right into it, because to really get Flight 10, you have to understand the enormous pressure SpaceX was facing. This wasn't just another test flight. No way. This was about proving that the most ambitious rocket ever built could finally overcome this one critical and very persistent flaw. So the program had basically hit a wall, a big one, and it was all about that massive second stage, the ship itself. After several flights, a really worrying pattern had emerged, and each failure taught a hard and very, very public lesson. I mean, just look at this track record. Flights 7, 8, and 9 all ended with losing the second stage. On Flight 7, it was taken out by a fire caused by propellant leaks. Then you have Flight 8, boom, a catastrophic explosion, all traced back to a single engine. And Flight 9, man, Flight 9 got so close. It made it all the way to its trajectory, but then just tumbled out of control coming back in. This pattern created what was truly a make or break moment for the next attempt. But here's the crazy part. Before Flight 10 even had a chance to fail in the air, the mission faced this wild, explosive setback right there on the test stand. It added a whole other layer of drama to an already incredibly tense situation. So the plan was all set. The hardware was ready to go. But on June 18, 2025, just 2 days after it aced an engine test, disaster struck. During what should have been a routine propellant loading for another test, Ship 36 was just completely obliterated in a massive explosion. And the culprit wasn't what you might expect. It wasn't an engine or some big structural thing. No, the official word was that a specialized nitrogen tank, way up in the nose cone, just gave out. It burst. This forced SpaceX to scramble right off the wreckage of Ship 36 and get a different vehicle, Ship 37, ready to go for what was now an even more crucial mission. All right, so new ship, new booster, they're finally ready to go. You'd think the drama's over, right? Nope. Turns out, just getting this fully stacked rocket off the pad was going to be its own fight. And this table really tells the story of just how persistent this team was. The first attempt on August 24th, scrubbed. A technical glitch, a leak in an oxidizer line on the ground. Okay, fine. They come back the very next day. What happens? The weather says no. Anvil clouds, a big no-go for launch. But they didn't pack it in. They came back for a third straight day. And that's when they finally got their shot. So, on August 26, 2025, Starship finally roars to life. And what follows is this incredibly complex dance. It's really two missions happening at once, a tale of two different vehicles, each with its own massive to-do list. And this just lays out how ridiculously complex this whole thing was. On one hand, you've got Booster 16. Its job? Get Ship 37 going, then pull this wild flip maneuver, fly back toward the launch site, and then try to nail a controlled soft landing in the ocean. At the same time, the ship has its own crazy agenda. Get to space, pop open the payload bay to release some test satellites, relight an engine in the vacuum of space, and then, the big one, survive that hellish plunge back through the atmosphere. Okay, so about a minute and 2 seconds into the flight, the vehicle hits a major hurdle called max Q. You can think of it as the moment the rocket is getting beat up the most by the atmosphere and its own speed. It's a moment of maximum stress, and it sailed right through it, no problem at all. A flawless ascent that set the stage for everything to come. And the successes just kept on coming. After separating from the booster, clean as a whistle, Ship 37 did something absolutely critical. It fired up a Raptor engine again in the vacuum of space. This is a huge deal for future missions, to the moon and Mars. And that one burn kicked it all the way up to its peak altitude, an impressive 220 kilometers above the Earth. But here's where the story gets really interesting. The flight was this incredible mix of huge, stunning successes and some really major, spectacular failures. And in the world of rapid development, that's not just a bad day. It's critical data for the future. So let's really dig into what they learned from all this. Because in the SpaceX philosophy, a flight that ends in a fireball isn't a failure as long as you learn from it. And believe me, Flight 10 provided some of the most valuable lessons they'd had yet. And man, the list of wins was long and significant. That innovative hot staging separation, where the ship's engines light up before it's even fully separated from the booster, worked perfectly. The booster flew back and performed its landing burn, hovering over the Gulf of Mexico before it splashed down. The ship deployed its payload, relit an engine, and even managed to pull off its landing flip maneuver right before hitting the ocean. These were massive, massive wins. But the failures were just as important. The booster lost an engine early on, which immediately informed future designs. The ship suffered a major explosion in its engine bay during re-entry, which they later traced to blocked engine shell lines. But here's the biggest takeaway, the most incredible part. The ship, despite being severely damaged and literally trailing fire, held together all the way to its landing flip. It proves to be far, far tougher than anyone expected, and that's invaluable data you just can't get from a computer simulation.
And this leaves us with a final thought. SpaceX's whole method of rapid iterative testing, building, flying, braking, and learning out in the open is a dramatic departure from traditional aerospace. That world relies on decades of careful simulation and ground testing to ensure perfection before a single flight. This spectacular trial-by-fire approach raises a fascinating question. Is this the most expensive way to learn? Or is it, in fact, the most effective?